So the first question says, a satellite TV package costs $125 per month for the basic package. So it's $125 for the month for the basic package, but then you have to pay an additional $5 per channel. We're creating a table of values to show the cost with up to 5 channels. So what's the relationship here? What are the two things we're relating? We're looking at a relationship between the cost and the number of channels. The cost depends on how many channels you're paying for, right? Think about TV. Okay, so the number of channels is independent. So when you're creating your table of values, look here, please. Number of channels, the independent variable always goes on the left side of your table. The dependent variable, always goes on the right side. So the cost depends on how many channels we're getting. So if you get 0 channels, reread the question. How much are you actually paying for this package? Raise your hand, please. It's $125 for the basic package. No channels, you pay $125 for satellite TV. If you added another channel, how much more do you have to pay for a channel? $130. You're paid $5 per channel, so it's going to increase by $5. What's 125 plus 5? 130. We need to make this up to 5 channels. 2, 3, 4, 5. What happens every single time you add a channel? It increases by 5. Good. So 130, 135, 140, 145, 150. Okay, so I already told you the independent variables on the left side. Independent is always X. Dependent is always Y. So we're going to put number of channels on the x-axis and the cost on the y-axis. So we start at 0, 0 always. And what would be a good scale for X? We're going from 0 to 5. Count by ones. Yeah, count by ones. Counting by ones along the x-axis. Now for the cost, the lowest cost is 125, the highest cost is 150. What would be a good scale? You can put the break in the graph, yes. And then let's start at 100. And what do you want to count by? Tens, fives, sure. Fives, 5, 10, 15, 20, no, fives we won't have enough space. So 110, 120, 130, 140, 150, 160. So we put the break in the graph to indicate that there's a break from 0 to 100, and then we count by tens. This is very important. The graph does not start at 0, 0. Where does it start? 0 and 125, and then it goes up by 5. Oops. Sorry, I can't really see on here. It goes up by 5 every time you get a new channel. So your graph should look like this. Does the graph form a straight line?
Yes. Yeah.
So this is very important. You're going to see this word throughout this chapter. If the graph is a straight line, it is linear. I want everyone to write this down.
Yeah.
Good. So before we describe the relationship, let's skip to D. It says, what would the cost be if you had 9 channels? Well, you can extend your table. Let's extend it. 6, 7, 8, 9. 6 channels would be how much?
170.
6 channels. 155. Then 160. Then?
165.
So 9 channels would be $170. So we know that looking at the graph, it's linear. What does linear mean again?
Straight line.
Good. We know now from the table, the table also tells us it's linear. Every time the number of channels increases by 1, what happens to the cost? What does it go up by? $5. Does it increase by the same amount every single time?
Yes.
Then you know automatically it's going to form a straight line.
Yep.
Please write that down.
Really, miss?
Okay, which of the following graphs are linear? Raise your hand if you think A is linear. Yes or no? Yes, how do we know? It's a straight line. Is B linear? Yes or no? No, absolutely not. It's a curve. Is C linear? Yes. A and C are linear. Okay, so X increased by 1 every single time and Y increased by 5 every time. It increases by the same amount. Okay, so we'll describe the graph we just made, number of channels and cost. We can say it has an upward, copy this down please, for question C. Describe the trend, upward positive trend, and describe the relationship. As number of channels increase, what happens? Good. As number of channels increase, the cost increases, we can say by $5, yes. But it doesn't start at 0, it started at 125 and then it increased by $5. That's how you would describe the relationship, okay? So, for this question, it says, which of the following relations are linear? Well, we don't have a graph, we have the table. How do you know if a relation is linear by looking at the table? What has to happen? Yes. What does that mean? It can increase or decrease. It doesn't have to just increase. But what's important? It has to increase or decrease by the same amount. Okay? Explain how you know. It must increase. Write this down, please. Or decrease by the same amount. Okay? A proper math term you're going to use is that it, write this down, is constant. You're going to see this word a lot this chapter, meaning that it increases or decreases by the same amount. It's constant. The rate of change is constant. Okay? Rate of change is constant. So the way it changes every time is constant. It doesn't change. Okay? So I'm going to give you a minute to figure out if A is linear, if B is linear, and if C is linear. Okay, raise your hand if you think A is linear.
It's going up by 8.
Thank you. Hours worked increases by 1, and for every hours worked, what do the earnings increase by? 8. So we would say linear, write this down, increases by 8. Increases by $8 per hour. Every hour it goes up by $8. It doesn't change all of a sudden. Okay, B. Shh. Number of coins go up by what?
B increased by 30.
Number of coins go up by what?
By 30.
10. Number of coins, you're not listening, go up by 10. Does the weight increase by the same amount?
Yes.
What does weight increase by? It's linear. Linear. As coins go up by 10, weight of the coin box goes up by 30 grams. Good? Okay. C. Does the starting height, increase by the same amount? Does the starting height increase by the same amount? Look at the table. This increases by the same amount, but does the time for a falling object to hit the ground? No, it doesn't increase by a constant amount, so we would say this one is non-linear.